Let's use this app to explain what a confidence interval is. Let's imagine we're trying to estimate the proportion of our student body that is committed to daily reusable bottle use. So we know that with thousands of students in the student body, that there is an actual answer. If we could ask everyone, then we wouldn't need a confidence interval. We would just ask everyone. But because we can't or don't or unable to, we pick a sample size, let's say 50, and we want to estimate the proportion of people or students, right, who are committed to reusable bottle use. Now, what we would do is we would conduct a sample, we would ask them, and then we would get a result. So you would draw a sample. Let's say we want to be 95% confident. We want to use a confidence level of 95%. This is just the procedure we're using, determined based off of normal probabilities distributions, that 95% confidence level means we're going to use a z-score or z-value, and we look at the key formula for that down here, right? That z-score is related to what we have been learning before with normal distributions. And so that helps us determine the margin of error, how much variance we could possibly see if we use a 95% confidence interval. So you would draw a sample, ask 50 students, and you get an answer. Now, you would get a sample proportion, a point estimate of 56%. But more than likely, we know that that answer is not the actual true answer. So that's why we used a confidence interval. And with 95% confidence, we have a z-score 1.96, which we learned before, right? Think about the empirical rule and normal distributions. A standard error is calculated. And then with those two values, we determine a margin of error. So we're 95% confident that the true proportion of students is between 42% and 69%. Now, what the 95% confidence level means, again, if we did 100 of these samples, and if I draw another sample, we would get a different value. You could see we would get from 42 to 6, well, actually, the first one. The second one here was between 50 and 77. There's variance in samples. The same 50 people, the 50 people are different. So you get all of these different samples if you could do it, right? And we end up with these different samples. And you continue to do it. After you do so many of them, you'll see we have lower bound and upper bounds here. We would want to estimate, what do you think is the true proportion of students? I'm 95% confident, right? I have a 95% confidence level using that, so that we are 95% confident that the true value is contained within these values here. Now, if we did 100, we would expect 95 of these to contain the true proportion. I don't know what the true proportion is, but now I have an estimate, right? An interval estimate to help me feel confident. So what would our estimate be? So if you look, 55 to 80, 46 to 73, 40 to 67. The true value does exist somewhere between. So if I had to guess, I'm going to say it's somewhere in between. I would guess between maybe 60%. That's just a guess now, because we will never know. So I'm going to reveal, I'm going to guess, and then the true proportion is 64%. We didn't know that ahead of time. The computer does. It gave us one, and then we built one around that true proportion, which we don't know. All we can do is estimate. But if we did know and found out later, 64%. But you can notice every single confidence interval contained the true proportion. We got lucky there. Remember, we would only expect 95% of them to. Now, if we use a 90% and 99%, different things happen. 90% confidence gives us a smaller margin of error. So the interval is smaller. 90% confidence, right? If we want to be 90, and then a 99% confidence gives us a larger margin of error, because we want to be more sure that we're capturing the actual answer. Hopefully that helped a little bit. Notice here, you have that formula there, and that's what we would do to calculate it after we do the sample. And last, hopefully you lasted all this way. Remember, we don't say there's a 95% chance that the values between these two numbers We can only speak that way before we actually do a sample. But once the sample is completed, we just say we have confidence.